In this video, I'm going to share with you my super secret slicer settings for creating 3D prints that can withstand unbelievable levels of abuse. How much, you say? Well, this is PLA, and with these settings, it can withstand this, and this, and this. Let's get started. How's it going, guys? Angus here from Muse, and this is Violent Crumble, my 150 gram ant weight class plant combat robot, or plastic ant weight. These tiny machines can only be constructed from a limited range of affordable and accessible 3D printing materials: PLA, ABS, and PETG. You can use cardboard, wood, or laser cut acrylic, but let's be real, most people 3D print these robots, and for good reason. It's an awesome way to get into combat robotics. And when I say these materials must be used, that includes things like the weapon blades. No crazy high-end nylons, polycarbonates, or TPU is allowed. So that begs the question, how do you make a blade from plastic destroy something else that's made from the very same plastic, but not break itself in the process? Well, it's taken several competitions and a ton of testing, but I am stoked to share my slicer tweaks so you too can turn the dial up on your part strength for any demanding application. And it all starts here in OrcaSlicer 2.3.2. OrcaSlicer has been my go-to slicer for years now, and with this latest stable release, it's more powerful than ever. It works with pretty much any brand of 3D printer on the market right now, and it has some really advanced settings that I've found are critical for squeezing just that little bit of extra strength out of my 3D printed projects. So what are these settings, you might be wondering? Brick layers, non-planar printing? Well, those are certainly really cool. Brick layers are a technique intended to minimize gaps between layers by dynamically adjusting the Z height during extrusions, like laying bricks, but it's still fairly experimental. You need an external script, you need to know your way around adding it to the slicer and tuning it. And then non-planar printing is also amazing, but even more challenging to implement currently. It swaps discrete layers for smooth flowing 3D surfaces that can give a much improved surface finish and in theory a stronger part, but it's simply not quite there yet. The method that I've developed, on the other hand, works totally fine in just the latest version of OrcaSlicer with no external scripting or modifications required, and it relies on just tweaking a few key settings to create a solid part which offsets large extruded lines to almost completely eliminate internal voids and dramatically improve part strength. And it all starts with the infill. For small parts where you want ultimate strength and density, like this combat robot weapon disc, you want a 100% solid part. And there's a few methods of doing this. The method I've seen the most is to simply increase wall count to a crazy high number, like 99. And that means that the part is printed with only walls, no infill at all, and it gives you a super dense and solid part. And this is what most people are using at the moment, and it works pretty well, but you'll notice how the layers are perfectly stacked on top of each other, and that's a problem. This arrangement creates inherent weaknesses in the part, which will cause it to split apart almost like it's shedding its skin. And there was actually an excellent example of this occurring at our most recent event, where after a few big impacts, the entire outer perimeter of a weapon disc tore off. Now, the idea of a part shedding its damaged outer skin to expose a fresh edge underneath is pretty interesting actually, but ideally it shouldn't happen in the first place. So how do we solve it? Well, there's this neat little setting right here: alternate extra wall. This setting adds one extra wall loop or perimeter every second layer. For example, with this cube, it's set to 2 wall loops, but with this setting enabled, it'll create an additional one every second layer, which sandwiches the infill between the outer perimeter of the part and increases part strength. It's a fantastic setting for strong 3D printing parts just in general, but in the case of our plastic combat robots, I was able to abuse it ever so slightly to create the 3D interlocking effect that I was after, and it all comes down to manipulating extrusion widths. If you're new to 3D printing, you might expect that a 0.4mm diameter nozzle can only lay down a line of filament that's 0.4mm wide, but that's not actually the case at all. By changing the ratio between how fast filament is extruded in relation to how fast the printer itself is actually moving, this extrusion width can be precisely controlled, and you can create some surprisingly wide extrusions with a standard 0.4mm diameter nozzle. In OrcaSlicer, this setting is called line width, and you can see the defaults here. Numbers between 0.4 and 0.5mm are pretty standard, but to achieve what we need here, what we need to do is set the inner wall extrusion width to half of the internal solid infill extrusion width. And you can see that here, I've gone with a 0.4mm extrusion width and a 0.8mm extrusion width for the internal solid infill. I'll be honest, 0.8mm extrusion width out of a 0.4mm nozzle is pushing it ever so slightly, but this is for the internal structure of the part that you'll never see, so it doesn't really matter, and modern slicers like OrcaSlicer will adjust print speed based on the volumetric flow rate setting in your filament profile, so you don't have to worry about the hot end trying to keep up with pushing that much extra molten plastic out of the nozzle. Now for the clever part. Instead of printing with only wall loops, you can instead use a 100% solid infill, setting it to concentric as the internal solid infill pattern. Don't worry about the sparse infill pattern because it doesn't matter at all once you set it to 100%. Without ticking alternate extra wall, this effectively doesn't do anything different to just setting your external walls to 99, but because that setting is ticked, it does this. You can see that it's forcing the slicer to stagger the pattern now, which allows the molten plastic to flow between the gaps of the internal concentric infill much better, and this in turn makes the part much stronger than if these layers were simply stacked on top of each other. Now obviously you won't achieve the strength of a perfect injection molded plastic part, but we're getting a little bit closer each time. And as a bonus, fresh off the press for OrcaSlicer 3.2.3 is a fancy new way of squeezing even just a little bit more strength out of this part, a feature called specific flow ratios. It's a really old trick, but you can actually force your printer to over extrude slightly by forcing more plastic out of the nozzle than you would normally, which would then force more plastic into the part, smushing the layers together a little bit better to add more strength. But this setting used to apply to the entire print, which would often completely ruin your part accuracy because you'd end up with outside walls looking like this. But now, as of this latest release, you can now select which path kinds use what flow ratio, and it's excellent for this kind of part. I'm still experimenting with how much over extrusion you can get away with, but just simply by changing the internal solid infill ratio and nothing else should help make the part even stronger without ruin accuracy. But as with all good things, adjust to taste. But of course, even with all these slicer tweaks, for some applications, you need strength that goes well beyond the realm of what desktop 3D printers are capable of producing, which is where this video's sponsor, PCBWay, can help. PCBWay can help turn your ideas into reality using a wide range of manufacturing processes, from CNC machining to laser cutting, PCB fabrication, and of course, 3D printing, but with industrial 3D printing processes. I've used PCBWay for years to manufacture parts for many of my combat robots, like these amazing titanium discs, which are used on Dead Cat Bounce to send opponents flying into the roof. And if you can design for 3D printing, you can design for CNC manufacturing as well. Simply export your design as a step file and upload to PCBWay, where you can select from a wide range of materials, processes, and finishes. Your designs will be checked by a real engineer who'll let you know if any changes are needed before the parts are made and then shipped right to your door. So why not give PCBWay a go for your next project? And you can use code PCBWay-MakersMuse10 for $10 off any order of $30 or more. To redeem the coupon, simply log in and at the top right, go to My PCBWay, My Coupons, and enter it below. Check out the link in the description below for more info, and a big thanks to PCBWay for sponsoring this video. To test out my brand new slicer settings, I created this single tooth disc and printed it on the Snapmaker U1 from a cheap roll of yellow Elegoo PLA+. I think it's pretty cool that you can see the concentric solid infill being formed and then printed over with a slight offset in the next layer. And it doesn't take any longer to print than any other 100% solid part setting. In this case, roughly 1 hour per disc. I also enabled ironing for all top surfaces because I figured it might help strength even more, but let's be real, I mostly did it because it makes the part look super smooth and shiny. The final part looks really clean with no evidence of over extrusion on the outer surfaces, and part accuracy is really good. Coming in at almost 30 grams, this thing feels super dense, and tapping it against a hard surface really has that solid tink that you would associate more with metal than a plastic part. But the question is, does this actually work? Well, I'm no CNC Kitchen, who has an excellent video exploring bricklayers, by the way, linked in the description below, but I do know how to test materials to destruction by building combat robots. So that's what I decided to do. I attached this disc to my nasty little horizontal spinner, Violent Crumble, which has been my test platform for my slicer iterations over the past 6 months. In a previous video I did on this robot, I had the embryonic stages of this super strong slicing method, but it was only with the latest OrcaSlicer release that I could dial them in exactly how I wanted. And it was also exploding its weapon motor every fight, so I ordered this new motor, which is much larger, but it also has a much stronger shaft. I can simply bolt the blade onto it with 2 M3 screws. I was really excited to see how these new settings would hold up, so I entered Violent Crumble into Robot Royale 8 held at the University of New South Wales, and well, this is how it did.
Epic 5. 10 seconds until the bit drops. Two, one.
It is hard to believe that this is regular old PLA Plus that anyone could print on any 3D printer out there. I only used 2 plastic blades for the entire event, with each seeing at least 3 fights. And the way that they've deformed is honestly pretty incredible. The first one dished out a ton of damage and hit the wall and the floor of the arena so many times that the paint is smeared all over it. This robot has almost zero control, and it has smoothed off, but it hasn't delaminated or broken in any way. And this second blade went on to do 5 minutes in the Rumble, which was held in the brand new Beetleweight arena with steel walls. And thanks to my excellent driving, I went full speed into these walls several times, ricocheting across the arena. And this disc actually hit the metal screws of a few of the competitors, and as a result, it has some of the tooth profile carved off. That's it, this is still very usable, despite hitting literal metal with PLA plastic. If you'd like to play with these settings yourself, I'll drop a link to the OrcaSlicer project file in the description below, so you can try them out in your own robot or any practical 3D print that you're working on. And I would love to know if you have any tricks for a super fancy or maybe slightly hacky slicer setting of your own that makes for strong 3D printed parts. If you enjoyed this video, then maybe consider subscribing, because here on Maker's Muse, it's my aim to empower your creativity through technology, and a big thanks to PCBWay for sponsoring this video. And with that, I'll catch you again very shortly here on Maker's Muse. Bye.